Yeah, so we are looking at this majority element problem today. Let's see, let's go. So, majority element given an array nums of size and return majority element. The majority element is element that appears more than by two times. You may assume majority element always exists in the array. So they are asking, could you solve this problem in linear time and in order of one space? Trying to say order of n time and order of one space, no new array, and as well as mm, no like n square or n log n kind of thing, right? The question is like if a element exists more than n by 2 times, that we want to know. Okay, so possibly we will need to keep the count of a given element and iterate the array one time at max or two times, not n times, right? So it would be n square. So how can we count a particular element if it is coming more than n by 2 times or not? Hmm. How can? How to? Suppose I count 2. 2 is 1. Then again 2. Again 2 is 1. So suppose these two were there, right? Um, and now 1 appears. So I'll have a max, okay? Max will be 2. Now 1 appears. So I'll make my counter 0. Then I'll start counting 1. 1, 2, 3. Now max became 3, right? Uh, 3 times we've counted them. Max is now 3. Now we come back to 2 and it is updated to 3. Now we count 2, but it is not big enough, so we cannot send 2 as the answer. It is asking the exact majority element, right? Okay, let me think. Give me some time. Okay, it is already solved. I might have already solved it. I'll not look at the submission though. July 18th, huh? Okay, let's see. Let me do it on my tablet. Yeah. I'll mirror my tablet screen. Let's say, let's go. So we are here at majority element, right? Not on this notebook, I'm sorry. No, I'm not sorry. On this notebook only, yeah. Majority element, and the element is going to be, get it an array 2 comma 2 comma 1 comma 1 comma 1 comma 2 comma 2. This was the first example, right? Yup. Now like as it is not sorted, we can directly just sort it and do it in n log n time. Space will be order of 1 only in that case. That is fine. Now if we sort, okay, if as as it is asking, like this is the only reason the interviewer will ask the question, right? Asking to wait in order of n time. So given given this array, we have to solve it. Suppose I'll keep a integer max, yeah, or answer. No, not answer. Integer temp max. Let's just keep it max. Max. I was not keeping the max because max is a still function, right? So that's why max equals 0. Now int count 0. Now let's run a loop. So while the element is there, on starting of this we'll just count it and check if its next is same. We'll then let's remove the logic here. We'll count this. I'll add the logic later. So we'll count this. This will become 1. We'll count this. This will become 2. Right? As soon as the number changes, number changes, I can decrement the count and keep the max, right? Or keep the max, right? Yeah. So max was 2. Now count is, I'm going to reduce it. We'll make it 1, and at this point my 0. As soon as it hits 0, I'll start incrementing it. We'll say now it's 1. Now it comes here again, decrement. No, not like this. This is not the logic. What can I do? Like 2 is clearly the major element, but my logic will make it make like 1 is the major element. And let's see in question some more things. In question they're saying nums of I can be negative 10 to the power 9 into 10 to the power 9. Alright, not just 2 values. Okay. Now, how to think about the solution? Do I need a better example? I guess this is good enough for now. We are at this point, then at this point, then at this point, then at this, and this, then that is called linear point. We start with 2 and we'll increase the counter. Uh, 0 to 1, 1 to 2. Now, if different type of like different value has occurred, 2 to 0, no, 2 to 1, 1 to 0, 0 to -1, right. So I'll remember at last place where it became 0, right? Let me think like this. So first 2 is 0 to 1, second 2 is 1 to 2, then first one is 2 to 1, then second one is 1 to 0. We'll keep this one in our memory. Okay, then we'll start incrementing back to 1, then we will remove this one to 0, and then again now as this has incremented, we'll keep this in memory, that is 2. Then it will increment it to 1. Yeah, I guess this can be the way you can store the answer. Last element which has made it a 0, right? Last element which has made it a 0 can be the answer. Now you can ask the intuition behind it. One can be the reason that I have already solved this question before by looking at someone else's solution. And other explanation could be, I mean this, I don't know this is the solution or not, but other explanation I can give you. See, only the element which has the which are going to occur the most, right, will be making it positive, right? Will be making it positive. So, like no other element is going to make it a 0. Since suppose, like, let me do this. Suppose we have comma 2, comma 1, comma 1, comma 1, comma. Now suppose we have added 3. So 1, 2, 3, 4, 5, 6, 7. In 7 element, majority will be 4. So 4 times 2. In 8 elements, majority should be 5, right? And by 2 plus 1, I believe. More than half it is saying. So 2 should be 3 times. 1, 2, 3. Let's do it here. Counter. Let's start with 2. 0 to 1, 1 to 2. Now 1 appears. So we will reduce it to 1 and we'll reduce it to 0. We had 2 in memory, now we have 1 in memory. We'll increment to 1. Okay, and then 3 appears. So 3 is different. So we'll reduce it to 0. Right, yeah. So 3 is in the memory now. 3. Now again 2 appears. So we cannot do anything, cannot go minus, going to be still 0. As it is 0, 2 will appear in the memory. Now again next to 1, next to 2. I mean, this is pretty intuitive. I hope by doing some examples you'll understand. What I'm trying to say is, if I'm taking a variable 1, suppose counter, I mean counter, that is going to be an integer starting with value 0, and I'm trying to use the same logic which I've shown. If you have not encountered any the given element, go till 0, like reduce the counter, and if you are at 0 with that element, means you have removed effect of all previous elements, right? Suppose we are dealing with only two type of variable, like 2 and 1, two types of value, right? In that case, you try to think about it, that you have reduced the effect of everything that 2 has caused. Suppose this was this much only, okay? So when you are at this point, you have removed all the effects of 2, essentially same. I mean, you are essentially same. So counter is 0, okay, and you are at 1. Suppose this last one was not there, so no one was, if the counter is 0, no one is the majority element, okay. And 3 4 5 6, yeah, no one is majority element. And if the counter is positive, and we have the in memory we have 1, because we have saved the memory as 1, counter is positive, you can say someone has surpassed 2. In similar fashion, I guess, if you imply your intuition, you can understand, like in similar fashion you can introduce n number of values, n type of values, and get the same result. Getting my point? Because ultimately what you're trying to do, like you are ultimately, whenever a variable comes, right, so like ultimately majority element will always reduce the effect of all other elements whose are n by 2. You see, simple example, I can just sort this out. 1 1 1, then 2 2 2 2 2, right, 5 times 2, and 1 times 3. So these 4 can only make this counter 4, even when, suppose, even when they are right now. What will happen in sorted this fashion? The counter will become 3, right, but these 3 will I'm sorry, these 3 will remove their effect. Yeah, these 3 will remove their effect, and these 2 will increase, but this cannot cancel out this effect. Only 1 2 will be still be there, right? This is barely n by 2 plus 1, like this is n by 2 plus 1, so last 2 will stand out and get the result. Let's code it. I hope you'll get it. You just try to get it intuitively. Just don't, if you're watching, I'm talking to myself as well, if you're watching this video, don't try to think like try to memorize the solution. Try to try to understand intuitively, and then practice some examples, and then you'll get it. Yeah. So now in this majority element, let's write down this code. So we'll need int counter, here saying you may assume the majority element exists in the array. If it doesn't, then we will be relying on this counter if it is 0. Okay, so no need to rely on the counter for now, but yeah, for counter is there, and another variable which we are going to take is int m, that is majority element. Now for n equals I'll do I equals 0. I should be less than n I plus plus, and if nums of I mean just keep the int first equals nums of I, and let's do this here. If first equals nums of I, will do counter plus plus, else like see we have got, if we have got some other element, we'll say if the counter is we'll do counter plus plus. If it is same to next, we'll do counter plus plus. If it is not same to next, right, then we'll do, yeah, then in that case we'll do counter minus minus. Okay, counter is not equals to 0. Okay, counter minus minus. Counter is not equals to 0, minus minus, else first equals nums of I, and if counter countr equals 0, m equals, so if I, maybe I'm doing too much. I do remember my last solution. M equals answer of nums of I. It was quite short. Like I just remember that bit. Like it was quite short. Return m. Out of my case, I believe some edge cases are missing from getting covered because I kind of do not believe the solution. Let me type out my case here. 1 comma 1 comma 1 comma 2 comma 2 comma 2 comma 2 comma 2 comma 3. So now 1 2 3 4 5 6 7 8 9 10, and 2 is 5 times. I believe it will say wrong example, maybe. Yeah, it has no. Let's remove this 2 and make this 1. Answer should become 1. This should be up there. And let me add one more test case. 1 comma 1 comma 1, then 2 comma 2 comma 2 comma 2 comma 2 comma 3. Okay, this is also running, this is also running, this one and this one as well. Need to check this out. So what is happening here is output is going to 0. That means you are not able to enter this loop, and we can do, in place of 0, just nums of I. Not a problem, right? Nums of 0. Okay, before submission, can I check my old solution though? Let it be. Let me submit it. Okay, it worked. Fascinating. Nice. Let me check my old solution, by the way. Okay. So we have count, we have answer, and if count equals 0, answer equals x. If answer x equals answer, x equals answer, you say. Alright, that's what I did. Okay. This solution and this solution. So if x equals answer, count plus plus, else count minus minus. Means if the last one equals to the answer, whatever we have determined as answer, count plus plus, else reduce the count. And when the count equals 0, it will automatically update the answer. Yeah, that is fine. In my case, Yeah, here I'm doing the same. If counter equals 0, I'll updating the answer to nums of that count I, and then incrementing it means the first into the m are both the same. Yeah, see, I see the redundancy here. So when the counter becomes 0, right? When the counter becomes 0, it automatically assigns first to nums of I. That is same as this. Okay, so maybe I can improve this. Yeah, but as for the solution, I guess I did pretty much good, right? I can use first. I can remove this m from here, and I can assign it nums of I or not. That is not required. I can return first, right? And I can remove this one. Wait. First will automatically change here, and then it will not go to negative, I believe. Yeah. Can remove this, can remove this, and can also remove this. Got it, got the point. That was fine, I guess. Count minus minus and just do it first here. And I believe this should also work then. Yeah. Fine then. Yep. So this is the